morning, class. Is everyone here? Am I audible? Can you hear me? Okay. So, before we start our formal class, we will have first a prayer. Who can volunteer? Okay, Mr. Arsenio, kindly lead. Amen. So, we will check your attendance. So, say cheese if you are cold. If you are present. Okay? So, Abragan. Arsenio. Marcelas. Kabato. So, wala si Kabato. So, Danag. Evangelista. Nyon. Lim. Manan. Wala si Manan. So, Ubida. Torno. Zanoni. So, only Kabato and Manan are absent. So, last week, we tackled about logic. So, who can recall what is logic and the types of logic? Okay, Miss Abragan? Yes, it is. So, as what we've tackled last meeting, so logic is a process for making a conclusion and a tool we can use. The foundation of a logical argument is its proposition or statement. So, we have the premises and the argument. So, premises are the propositions used to build the argument. Then, the argument is built on premises. So, any questions or clarifications before we proceed to our next topic? Questions about logic? None? Okay, so let's proceed. So, today we will tackle about equivalent statement. So, do you have any idea about what equivalent statement? Yes, Lim? Okay, the statement is equivalent, correct. So, another idea. None. So, equivalent statements are statements that are written differently but hold the same logical equivalence. So, when the statements are both true or both false, then the statement is equivalent. So, it means that they have the same or equal equivalence of statements. So, before we proceed to the example, we will know first the symbols, the meaning, and the rules. So, this symbol means and. So, we read as A and B. So, next, we have this symbol means or. So, we read as A or B. So, these symbols means negation. So, we read as not A. Negation or not. So, we read as not A. So, this symbol means implies or if and then. So, we read as A implies B or if A, then B. So, lastly, we have this symbol. So, it means if and only if. So, we read as A and if only B. So, that's the symbol and their meaning. So, a logical conjunction is an operation on two logical propositions that produces a value of true if both its statements are true and is false otherwise. So, it uses the logic symbol and. Then, a logical disjunction is an operator on two logical propositions that is true if either statements is true or both are true, and is false otherwise. It uses the logical connectives or. Then, a negation is an operator on the logical value of a proposition that sends true to and false to true. It used the logical NOT operator. Then we have the implication. An implication is a type of compound statement that is formed by joining two simple statements with the logical implication, connectives, or operator. So the truth value of the compound statement is true when both are true or both false, and when P is false and Q is true. So the only scenario that false happens is when P is true and Q is false. So remember that. In implication, the only scenario that false happens is when P is true and Q is false. So otherwise, the statement is true. So lastly, we have the double implication, also known as the biconditional statement. So it is the if and only if. So it is type of compound statement that is formed by joining two simple statements with the biconditional operator. A biconditional statement is really a combination of a conditional statement and its converse. So it is denoted by a double-headed arrow. Okay? So the truth value of the biconditional statement is true when both simple statements are both true or both false. Otherwise, the statement is false. Okay? So when the statement is both true or both false, so it is automatic that the statement is true. So otherwise, if the when P is false, then the Q is true, so the statement is false. Okay? So any questions? So we will have an examples for the equivalent statements. Questions about these logic symbols or rules? Okay, so we will have an examples. So we will prove the following equivalences by throwing the truth tables. So we will use truth tables to prove the equivalences. So we have this first example, not P and not Q is equals to not P or Q. So we have a constant P and Q. So true, true, false, false. So true, false, true, false for Q. So we will negate this P. So it becomes to not P. So true, it becomes false, true, false, false, true, false, true. So next we will negate Q. So it becomes not Q. So true becomes false, false, true, true, false, false, true. So you will get this inside the parentheses before we will negate this P or Q. So we have P or Q. So since it states that the logical disjunction or logical OR is true if either statement is true or both are true and is false otherwise. So it is more on true statements. So P or Q will base this to this P and Q. So since it is true, both true, so we will come up true. So true, false. So since it's have a true, so the statement is true. So false, true, it's also true. So false, false, so it is false. So next we will negate this P or Q to get this. So we'll negate true becomes false, true, false, true, false, false, true. So we will see if this statement is true to these statements not P and not Q. So not P and not Q, so we will base this. So since the logical conjunction or the logical end states that it is true if the statements are both true and false is otherwise. So it is true when it is only true when the statement is both true. So we have the both false, so it comes false. So false and true, so we have false. So true, false, the statement is false. So it since the both true, so we have true. So we have the equal statements. So this statement is equivalent. It is true. Okay? So let's try to this next example. So we have P. If P and only if Q is equals to P implies to Q and Q implies P. So we have the constant P and Q. So true, true, false, false, true, false, true, false. So next we'll get the statement P implies to Q, or if P then Q. So since in the implication states that only false if P is true and the statement and the Q is false. So we'll base this. So since it is true, both true, so we have true. So true, false, 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 true, it comes to true, and false, false comes true. Next, we will get this Q implies to P. So it implies to P. So baliktad. So true, true comes true. Then false, true. Since the P is false and the since the first statement is false and the second statement is true, so it comes to true. So true, false. So nabaliktad siya. So the first statement is true and the second statement is false. So since we implies to second statement, so the result is false. So since it lastly we have the both false, so comes to true. So next we get this P. P, if P, then if P and only if Q. So in the biconditional statement, it is state that it is true if both true or both false. So P if P and only if Q. So we will base this. So since it is both true, so we have true, true, false, 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 true, false, and both false, we have true. And next we will see if this statement is equals to this statement. So we have P implies to Q and Q implies to P. So we'll base this to column. So true, true, we have true, false, false is false, and true equals to true. So we have the same values of statements. So this statement is true. Okay? So we have the last example. So P implies to Q or R is equals to P implies to Q or P implies to R. So since we have the P three arguments P, Q, and R, so we have P, Q, R. So P true, 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 false, 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 and Q true, true, false, false, true, true, false, false, R true, false, true, false, true, false, true, false. So first we will get this Q or R. So we will base to this two column. So or true, true equals to true, true, false equals to true, false, true equals to true, since or is more on true, right? So false, the only statement is false if both are false. So false, false, we have false, and both true, 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 false equals to true, false, true is equals to true, and both false is equals to false. So next we'll get this P implies to Q. So P and Q. So implication, only false if P is true and Q is false. So P and Q, both true is equals to true, both true is equals to true, true, false equals to false, true and false equals to false, false, true equals to true, false, true equals to true, both false equals to true, both false is equals to true. So next we will get this P implies to R. So P and R. So true and true is equals to true, true, false equals to false, true, true is equals to true, true, false equals to false, false, true is equals to true, false, false is equals to true, false, true is equals to true, and false, false is equals to true. So we will get this P implies to Q or P is equals to R. So we will use these connectives or. So it means it is more on true. So P implies to Q and P implies to R. So true, true is equals to true, true, false equals to true, false, true is equals to true, both false is equals to false, true and true is equals to true, true, true is equals to true, both true is equals to true, and both true is equals to true. So we will see if this statement is equals to this statement. So P implies to Q and R. So we will base this P and Q or R. So in the implication, we have the only false if P is true and the second statement is false. So P and Q or R. So both statement is true. So we have true. True, true is equals to true. True, true is equals to true. True, false equals to false. False, true is equals to true. False, true is equals to true. False, true is equals to true. False, false equals to true. So we have the same value of statements, of propositions. So it means that this statement is true, that P implies to Q or R is equals to P implies to Q or P implies to R. Okay, do you get it? Okay, so that's it. So do you have any idea, any questions or clarifications about the equivalence statement? Class, do you hear me? So if none, then we will have an activity, 15 minutes activity. So you have, I will give you 5 statements and you will prove this by using truth table. So for your answers, you will just PM me before 15 minutes, okay? And for your assignment, I will just post it in your Google Classroom, okay? Including the rubrics and the deadline. Okay. So the time is 9:17. So before 9:32 a.m., you will pass the activity. Otherwise, I will mark late. Okay? So please open your camera for the documentation. Mr. Arsenio, open your camera. Okay, 1, 2, 3. Okay. You can now leave the meeting class. Okay, goodbye. Stay safe, everyone.